All right, so in today's video, we're going to tackle one of the harder topics for an Algebra 1 student. It's solving systems of equations. There's multiple methods you can use, right? You can use elimination, substitution, graphs, or even matrix algebra. We're just going to stick with elimination for today. Before we get started, we're going to thank our corporate sponsors, Sticky Feet Reptiles at stickyfeetreptiles.com and the Crafty Badger. So the steps to solving systems of equations with elimination. First thing you want to do is you want to make sure everything lines up vertically. So you're going to line your variables up, x over x, y over y, constant over constant, or whatever variables you have. Make sure they line up vertically. After that, we're going to make one set of variables, so either the x's or the y's, opposites from one another. That way, in step 3, when we add the two equations vertically, one or more of the variables will cancel out. They'll eliminate each other. After that, we're going to solve for the remaining variable that we have, substitute that result into one of the original equations, and then solve for the other variable and write the solution as an ordered pair. And after that, as in all good math processes, you should check your work. So let's take a look at an example. So if we take something like this, right? This is going to be our first example. I have negative 5x plus y equals negative 4, and 4x minus 4y equals 16. So if you look at your x's or look at your y's, you want to see which one looks easier to eliminate, right? Well, if I look at the x's, I have a 5 and a 4. I'd have to multiply both of them by something for them to have something in common, right? I can multiply this by 4, this by 5, so they're both 20. But that seems more work than I want to do. So if I look at the y's, I have a 1 and a negative 4, right? 1y here, negative 4y here. What could I multiply this first equation by to get the opposite of negative 4, which would be positive 4? Well, I could just multiply this first equation by a positive 4, right? Because 4 times y would be 4y. 4y and negative 4y are opposites, and they would then cancel out. So if I do that, make sure when you multiply this, you distribute that 4 to all three pieces. So if I take 4 times negative 5x, that gives me negative 20x. 4 times y is 4y. And then 4 times negative 4 is negative 16. So now I'm working with these two equations, the original second equation and the first equation that I altered by multiplying everything by that 4 value. Right, so my next step says I want to add those two equations vertically. So if I add these together, 4 plus negative 20, same as 4 minus 20, is negative 16x. The 4 and the negative 4 will eliminate, they'll cancel out. And 16 minus 16 is 0. So this one works out pretty nice because if I want to solve for x, the remaining variable, I just divide by negative 16, and 0 divided by anything is 0. So I get x equals 0 for the first piece. Now I'm going to take this 0, put it in, substitute it in for either one of the x's in the original equations. So pick one. I'm going to go with the first one just because it's the first one. So I'm going to have negative 5. Instead of x, I'm going to put a 0 in. So I'll put that here. So 0 plus y equals negative 4. So you can see I took this original equation, the first one, and I just put a 0 in for the x. Well, I know that negative 5 times 0 is just 0, so that's gone. So then my y value is just going to equal negative 4. So when you write your solutions, you want to write them as an ordered pair. So x comes first, and then negative 4 comes second. Right, and if you want to check your work, you can go back to the originals and plug this 0 in for x and the negative 4 in for y. So if I put a 0 in for x, negative 4 in for y, it should make both of these equations true. And it does, right? But you can check it if you would like. The next example we have here, we'll do 3 examples total. So pretty similar. right? I have x's and y's, almost similar x and y. If I have positive 4 here, and I want to get rid of that, I need a negative 4 down here. Well, the negative I already have, but the 4 I do not. So I need to multiply this second equation by 4. If I do that, I get 16x minus 4y if I distribute, and then 4 times 8, 32. So now I'm working with the original first equation and the altered second equation, right, when I multiplied everything by 4. So if I look at those, if I add them vertically, I get 5x plus 16x, 21x, 4y minus 4y, they will cross out, and then 10 plus 32 is 42. If I divide the 21 over, I get x equals 2. Once I have my x, I'm going to take one of the two original equations, substitute in for x, 2. So I'm going to pick the first equation again for no real reason other than it's the first equation. So I have 5 times, instead of x, I'm going to put 2, and then plus 4y equals 10. So if I do that, I get 10 plus 4y equals 10. Subtract the 10 over, so I get 4y equals 0. Divide by 4, anything divided, or 0 divided by anything is, of course, 0. So my x was 2, my y was 0. I'll write my solution as an ordered pair, 2, 0. Right? So that's not too bad. Now, let's look at one of those special cases, right? So this is one of our special cases. We have 2x minus 3y equals negative 7, and negative 4x plus 6y equals negative 10. If you look at the first equation, if I want to get rid of the x's, I say I have a 2, I need a negative 4. The opposite of negative 4 is positive 4. So what would I multiply 2 by to get positive 4? Well, I'd multiply it by 2. So if I distribute that 2 through to everything, I would get 4x minus 6y, and 2 times negative 7 is negative 14. So if I add those vertically, negative 4 plus 4 cancels out. It eliminates the x's. But in this case, 6y minus 6y also cancels out. So I'm left with nothing on the left side, and then negative 10 and negative 14 gives me negative 24 on the right side. When you cancel your variables out, you have two possibilities. If it's a true statement like 0 equals 0, then that's going to be infinitely many solutions. All numbers, all real ordered pairs would work in that. If you get a false statement like 0 equals negative 24, that's not a true statement, so that means there is no solution that would work in that system, right? So that's going to be a no solution problem. We hope this video helps. Make sure you like and subscribe, and please feel free to comment on suggestions, or if you have any videos that you'd like us to put up in the future, we're open to new ideas. Thank you for watching. See you next time.